Okay, so we have node voltage method number 5, NP5 here, NP5 from the node voltage series. So what we have is a voltage source right here in an amount of 10 volt. And then we have a resistor here going all the way. And up here we have another resistor. And here down below we have a diamond, another diamond, and another resistor right here. So this is our ground. Here's a ground terminal, and we have a current called I sub x flowing through this leg, which has a resistance of 4 ohm. Here is our node number 1. Up here we have 4 ohm. This is a diamond containing an arrow. 2 times P sub y. What is P sub y? P sub y is the voltage across this resistor, whose resistance is 2 ohm. And then we have plus and minus in this diamond, as output is 4 times I sub x, where I sub x is the current we talked about here going through 4 ohm. So this is node number 2, and right here is our node number 3. So what is the end plan? The game plan here is to come up with a matrix that describes this circuit using a node voltage method. So if we look at node number 1, we realize quickly that the I sub x is from Ohm's law, P1 over 4. Okay. And likewise, if we look at node number 3, we quickly realize P sub y is simply P sub 3. So these expressions help us understand the diamonds because these appear as the output of the 2 diamonds. Next, we also see at node 1, P sub 1 is 10 volt. Now, finding this thing, we're about ready to send this box to our matrix. Here it's got 1, all of P sub 1, and none of P sub 2, and none of P sub 3 will give us a total of 10. So this box is ready to go to our matrix. Next, if we consider this supernode Sn, as we write, consisting of the nodes 2 and 3, 2 and 3, what we see is the voltage drop between nodes 2 and 3 is the same as the diamond 4Ix. And remember, I sub x is P sub 1 over 4. In other words, we can write that P sub 2 minus P sub 3 is 4 times Ix, and I sub x is P sub 1 over 4. The two 4's cancel out, leaving us P sub 1. So if we transfer P sub 1 to the left side, we're going to get P2 minus P3 minus P sub 1 equals 0. Now this is giving us the next box. Here we have minus 1, P sub 1, and 1 of P sub 2, and minus 1 of P sub 3, giving us a total of 0. So the second box is ready to go to the matrix. What else we have? If we consider the supernode consisting of node 2 and 3, and then we can consider the KCL at this supernode, it's got the 1, 2, and 3 legs. Onto the floor, we have current flowing from the supernode in an amount, but let me write this case here at Sn, in an amount given by P sub 3 over 2. What else? And coming from the left onto node number 2, we have 2 sub p, 2 times p sub y coming towards the supernode. So using passive sign convention, that's going to sign minus. Then up through the bridge, P2 minus P1. That's the voltage drop across the resistor for ohm. And this is leaving the supernode. So plus sign equals 0. So we can rewrite this thing as P sub 3 over 2 minus 2. Realize that P sub y is simply P sub 3. So we write P sub 3 plus P sub 2 minus P sub 1 over 4 equals 0. And to simplify this, what if we hit hard with something big such as 4? If we multiply the whole thing by 4, we take out the denominators. So it's going to give us 2 and 4 cancels, so 2 times V sub 3 minus 8 times V sub 3, and 4 in the denominator cancel with the 4 in the numerator, so giving us V sub 2 minus V sub 1 equals 0. That is to say, we have minus 6p3 plus p sub 2 minus p sub 1 equals 0. Let's put this in a box. Namely, we have minus 1 p sub 1 and 1 of p sub 2. Hang on just a sec. We will clean a little bit here. Okay, so that will do it. So let's go back. So we have plus minus 6 of p sub 3 equals 0. So this is the third box, ready to go to the matrix. Therefore, the matrix form is formed as this. Let's put the matrix here, B1. We might have to squeeze a little bit here. Kind of narrow. Let's go ahead, fill in this with the voltage vector, V sub 1, V sub 2, and V sub 3. On the left, we will have 1, 0, 0, giving us 10 on this side. Then minus 1, 1, minus 1, giving us 0. Finally, minus 1, 1, minus 6, giving us 0. So the matrix is complete. Well, I hope you enjoyed watching me do it. Take care.